This video shows how I built my new luggage rack for my 2006 Ninja 250. Several years ago, I designed, built, and published plans to build a luggage rack for the Ninja 250 that was made out of chromoly steel. That rack worked very well for over 30,000 miles, but it had some annoying faults. The most notable fault was the fact that it was difficult to build because it was welded together, and welding 4130 chromoly steel is not a skill that everyone has. Another problem was that the deck was parallel to the ground, which prevented vehicles in the rear from seeing the brake light if they were too close. And lastly, although chromoly steel is very strong and light, it's prone to fatigue cracking, which caused me to have to re-weld it several times to fix the cracks. Although it actually worked very well, I decided to design a new one from scratch that's built from aircraft aluminum and requires no welding whatsoever. The deck of the new version is higher and tilts up at a slight angle, so the taillight can be seen by even the tallest trucks. In addition, the new design uses 2024 aircraft aluminum and is actually stronger and more resistant to fatigue cracking. Now, if you think you might like to build one, you can find links to free downloads of the plans for both the new and the old designs on my blog site. While there is no welding required to build the new rack, if you build one, you'll still need access to several basic shop tools. At a minimum, you're going to need a vise, a grinder with a wire wheel, some kind of metal cutting saw such as a hacksaw or metal cutting blade in an angle grinder, a hand drill, an accurate measuring device such as a caliper, and some small C-clamps. Although it's not absolutely required, a drill press and a metal lathe are very handy. One tool that you will need, which isn't all that common, is an air riveting hammer. And this requires an air compressor. An air riveting hammer is an air-powered hammer that delivers rapid and powerful hammer blows to solid aircraft rivets in order to squish them. It looks and works a lot like an air chisel, but delivers about 10 times the force. It's very tempting to just use a $10 air chisel, but it just doesn't have enough force to do the job. If you have to buy one, an air riveting hammer and bits will set you back about $100. You might be thinking that you could just use commonly available pop rivets, but they simply aren't strong enough. The rivets in this design are under a high shear load, so even steel pop rivets won't be strong enough. If using an air riveting hammer is not practical, you can use little machine nuts and bolts in place of the rivets. Lastly, another tool that makes things a lot easier is a set of clecos. Clecos are essentially temporary rivets that can be used to temporarily hold parts together. Once you have all the tools, you'll need to get the materials. As I mentioned before, this rack is made from 2024 aircraft aluminum, specifically 2024 T351. I know it's tempting to just run down to the local hardware store and pick up some overpriced aluminum for this project, but don't. The stuff that's sold in hardware stores is generally 6063 aluminum, which is far too flimsy to work in this project. It's best to order the materials from aircraftspruce.com or another reputable metal supplier. Even with shipping, it's actually much cheaper than the junk they sell in the hardware store. I've included a list of all the materials you'll need along with the Aircraft Spruce part numbers in the plans. Once you have all the necessary tools and materials, it's time to get started by printing out the plans. The plans are designed to be printed at full scale. It's very important to check the printed plans to make sure that the part dimensions are exactly what they're supposed to be. Several of the parts are 1 inch wide, and that can be verified by measuring. If the printed parts aren't exactly the right size, you'll need to adjust your printer settings until they are. Next, cut out the lower mount bracket, lower ascending arm, and upper ascending arm. These cutouts will be used as patterns to make the parts. I'm going to use spray glue to stick the cutouts to the metal, but plain Scotch tape works too. Notice how I take advantage of the factory square ends. Using my angle grinder with a metal cutoff blade, I'll now cut out the lower ascending arm. Once that's done, I can flip the part over and use it as a pattern to cut the lower ascending arm for the other side. Isn't it slick how the angles line up exactly? Now I'll cut the lower mount bracket. And the other side for that as well. The upper ascending arm is a little more complicated because it has angles on both ends. But I can still use the same trick to cut the second part. I need 4 side plates to hold the arms together. These are just 4-inch long sections of the 2-inch wide stock. I'll cut them now. Now the top angle aluminum rails need to be cut. I start by measuring 10 inches. Then cutting. Then cutting the second using the first as a pattern. Now I need to cut the angle brace. It's 7 1/4 inches long. There's only one and it gets cut the same way. Now I'm going to deburr and wire brush all the ends so that they are smooth and free from sharp edges. This is how the parts will fit together. They get sandwiched together between 2 side plates and held together by solid rivets. In order to install the rivets, I need to drill holes in the pieces I just cut. First, I center punch all of the holes marked on the paper cutouts. I only do this for the lower mount bracket and the upper and lower ascending arms that have the paper cutouts stuck to them. The side plates and angle aluminum are not center punched. Next, I'll drill all the holes using a 1/8 inch bit, including the larger holes. Now I'll clamp the drilled parts to their undrilled twins and drill those as well. That way I don't have to center punch the second set. Drilling the side plates is a bit tricky. I start by using a paper clip to hold a second plate like this to create an edge halfway across. Now I place the square end of the lower ascending arm up against it like this. I make sure that the lower ascending arm is oriented properly, and then I clamp it down. Using the lower ascending arm as a template, I drill the first set of holes in the side plate. I'm using cleat hose to hold the lower ascending arm in place while I drill the other holes. The lower mount bracket fits against the end of the lower ascending arm like this. Notice how the top corners are exactly even. Then I'll clamp it together. You'll also notice that the bottom corner sticks out a little bit, but that's okay. Now I'll drill the second set of holes in the side plate and add cleat hose to hold it on. This is how the upper ascending arm fits. Notice how one corner meets up with the top corner of the other two parts. And then I'll clamp it. Now I'll drill the third set of holes in the side plate. Now that the first side plate is completely drilled, I'll use it as a pattern to drill the other three side plates. With everything drilled, I'll dry fit everything together using cleat hose. And I'll put in a rivet to get ready for the riveting hammer. I use the air riveting hammer to squish 2 rivets in each piece. Now I can remove the cleat hose and finish riveting all the holes in the side plate. When done, the 2 arms should look like this. Because there is a factory side and a squish side of the rivet, I made sure that both arms will have the factory side of the rivet spacing out. Now it's time to drill out the 2 larger holes in the lower mount bracket using a 1/4 inch bit. It's easy because I've already drilled these holes out with the 1/8 inch bit. I'm going to grind the sharp corners off the end of the lower mounting bracket for safety. With that done, I'll go ahead and clamp the angle aluminum to the arm assembly like this. I need to double check which side I'm using because the arm on one side of the bike has the angle aluminum going one way and the other side has it going the other. I use the holes in the arms as a pattern to drill the aluminum angle. and then rivet it together using the air riveting hammer. When they're done, they should look something like this. The rack will mount to the bike using the cargo hook bolts on the side. The original bolts have beveled heads. Since I want to have a gap between the sidearms and the bike, I need to make some spacer tubes. These spacer tubes are 1.1 inches long and have a bevel on one end to match the bevel in the cargo hook. One way to make a bevel is to use a grinder. The drill bit sharpening groove is just about the right angle. But since I have a lathe, I'm going to use that. With the lathe, I can also use the parting tool to cut the tube to the exact length. In addition to the two cargo hook mounts, each side also mounts to the grab bar. There are two bolt holes on the bottom of the grab bar, one on each side. To connect the sidearm to the grab bar, a steel bracket must be made. I had to use steel because the 2024 aluminum is so hard that it won't bend without breaking. This bracket is made of 4130 chromoly steel and is much easier to bend. First, I have to mark and cut off a 4-inch length. Then I use the plans as a pattern to mark exactly where the bends will be. Bending is done in the vise. I use a square to make sure that it's perpendicular to the vise. Then I use a hammer to make the first bend, which is a simple 90 degrees. The second bend is a little more difficult. I use a scrap piece of angle iron to bend it over to the correct 70 degrees. Then I check the bend by comparing it to the printed plans. The steel brackets will be attached to the sidearms using solid rivets. The rivet holes have to be drilled in place, so I'll have to temporarily mount the unfinished sidearm to the bike. The bracket will fit right in there like that. For now, I'm just using small C-clamps to hold it in place. One on the bottom and one on top. Using a Sharpie, I mark where the bolt hole will go. Then I can remove the clamps and center punch where the hole will go. Then I first drill an 1/8 inch hole, followed by a 1/4 inch hole. Then back over on the bike, I bolt the bracket to the bottom of the grab bar. Adjust it for a proper fit, and use a wrench to snug it up. I'll add a clamp on the bottom to get ready to drill the top holes. I put a small scrap of wood behind the hole so the drill doesn't damage the plastic. Once the top holes are drilled, I put a cleco in one of them and then remove the clamp from the bottom. Then I drill the bottom holes the same way I drilled the top ones, and add clecos to keep things in place. Now I unbolt everything and remove the assembly from the bike, and then rivet the bracket onto the arm. With that, the sidearms are complete. The only thing left is to attach the top plates. To do that, I must first bolt both the sidearms back onto the bike. Now, you can see there's a little problem. Because the top rails are at an angle, I have to make little wedges to fit in here so that the top plates will sit flat. But before I do that, I have to measure and cut the top plates. There are 3 top plates and they are all different lengths. One goes in the front, the next in the middle, and the last at the rear. Notice how I numbered them so I can easily keep track of them. Now I need to mark a single hole on the end of one of the plates. I'm using a caliper to mark the hole 1/2 inch from the end and 3/8 inch from the side. I only need to center punch one hole. Then drill it out. Now I clamp that plate onto an undrilled plate and drill the hole through that plate too. When that's done, I can flip the original plate and drill the hole on the other side of the second plate. Turn it over and drill the second hole back in the first plate. Now I have a template to drill the ends of all the other plates in exactly the same spot. When all the plates are drilled, they look like this. Now I still have the problem of how to make the wedges. There are several ways to handle this. I could cut wedges out of oak or solid nylon, or even machine the wedges out of aluminum, but those methods are too time-consuming. I decided to cheat a little bit and use a product called Quick Steel. It's basically an epoxy resin Tootsie Roll that hardens after being kneaded and mixed. I cut the roll into 6 evenly sized chunks and used one chunk for each end of the top plates. I sprayed a little WD-40 on the top plates so that they didn't stick to the Quick Steel, but I was careful not to contaminate the Quick Steel with WD-40 and ruin it. I put the Quick Steel on the top rail and then squished it with the top plate and held it in place with some duct tape. If any Quick Steel squeezed out where it didn't belong, I just pushed it back in. After a few hours, the Quick Steel hardened solid. At that time, I located the holes in the end of the top plates and drilled them straight down through the Quick Steel and the angle aluminum. These holes will be used for the 8/32 machine bolts to hold the top plates on. But an 8/32 bolt will not fit through an 1/8 inch hole. So the holes in the top plates must now all be enlarged using a 3/16 inch bit. And the holes in the angle aluminum must be tapped with an 8/32 tap. Because I'm careful, I can use my drill to simplify the tapping process. Now, with all the holes tapped, an 8/32 bolt should screw right in. If so, then I can go ahead and screw down all the top plates. Now there is one last task that needs to be completed. I need to add an angle brace across here like this. It will fit in there like that, after it gets riveted. But first, I need to mark the holes. I start by finding the center and marking that. Followed by 3 marks exactly 1 inch apart on each side. Now I center punch all 7 marks. And drill them. Then I align the center of the angle brace with the center of the middle top plate and clamp it together. And then drill the matching holes in the middle top plate. Followed by riveting all 7 holes. And the luggage rack is now complete. I went ahead and added these lock nuts to the bottom of the 8/32 bolts. They are just loosely fitted and act as a backup in case our cut threads don't hold up. I should also mention that I put lock washers under all the main bolts as well as all the 8/32 bolts. So far, nothing is vibrated loose. Also, I used the angle grinder to grind off this little tip that sticks out, as well as the excess plate material here and here. When everything was done, I took it off and painted it, and installed my trunk. Then I loaded it down with a bunch of camping gear and took it on a 700-mile trip around the state. I didn't have one single problem with the rack. So I'm thinking if you want to build one just like it, you'll have a solid luggage rack that will give you many years of reliable service.